I'm Tim Ventura, and we're joined today by Dr. Amri Wandel, a senior scientist in astrophysics at the Racah Institute of Physics at the Hebrew University of Jerusalem. Dr. Wandel is an expert in astrobiology and chairman of the Israeli Association of Astrobiology in Early Life. He's also the president of the International Academy of Sciences in San Marino. His main research topics are high-energy astrophysics, black holes, active galaxies, quasars, and astrobiology. He's published over 100 professional articles in the world's leading journals in the field of astrophysics and joins us today to discuss artificial intelligence, astrobiology, and the search for extraterrestrial intelligence. So, Omri, welcome, sir. Thank you so much for joining us today. Today, we're discussing the paper, Will Recent Advances in AI Result in a Paradigm Shift in Astrobiology and SETI, which was published in the International Journal of Astrobiology. So let me start by asking what inspired yourself and your colleagues to write this paper?
Oh, thank you so much for inviting me. It's my pleasure too. So this paper is actually the lead author on this is my colleague Joe Gale, who had the idea, and we collaborate for a long series of papers on astrobiology, and also we have similar courses, he in astrobiology or more biology, and I more in astrophysics, but we joined forces. And one of this collaboration gave birth to this idea. Since people talk about the singularity, when machine power will surpass the brain power of biological creatures like humanity, and what will happen then? And this will have a big impact, supposedly, even on things that we now take for granted, like communication, and less granted interstellar communication, and things like SETI, the search of extraterrestrial intelligence. Because right now we are looking under the lantern. We are looking for life forms that are similar to us, that are carbon-based, liquid water-based, and perhaps we are looking in the wrong place, because when the singularity arrives, or a few centuries later, machines will be much advantages in exploring space. We'll talk, I saw your question, we'll talk about it later. But since we are actually a new upcomer to the SETI business and to the space travel and interstellar communication, it is likely that most civilizations, putative civilization, one should say, because we didn't find even one yet, most of those are much older than we are, and therefore they will have passed their singularity, and then maybe they will operate by machines or by symbiotic machine, biological or whatever. So maybe we are looking the wrong conditions. So we should not be looking for the habitable zone, which is defined as a place where liquid water can exist on the surface of planets, but we should look for a machine habitable zone, that is computer habitable zone, which is good conditions for computers. As we know it now, maybe we'll need low temperature, much lower than a freezing point, because then it's more efficient. And we probably will need to be away from planets, because there is much noise and things that are not so perfect for machines. So this may change, as we said, it may cause a paradigm shift in looking for intelligence.
Yeah, well, when I read your paper, I got so excited about it. And one of the reasons is I think the intersectionality between machine intelligence, and extraterrestrial intelligence, as well as just so many of the big ideas that you guys are exploring in it. So let me break it down. I want to come back to artificial intelligence and Moore's law. Do you think that advances in AI and Moore's law make the singularity inevitable here on Earth for us?
Yeah, I believe so, but I don't believe that the singularity will necessarily be something traumatic or something that will extinguish biological life as we know it. We have no idea what will happen when machines are become stronger, power thinking, or AI become more advanced than human intelligence. It may be, well, people have thought about all these possibilities and published it in countless number of science fiction novels. But any scenario can happen. It can be a symbiosis, there can be a collaboration, there can be a machine revolt that will try to say, well, the humans are so weak and so compared to us, there is a waste of things, of resources, so we kill them all and continue on ourselves. And they may also be, humanity may, along with genetic engineering, they also may do genetic machine engineering. So be composite part of our brain, and the body will be machine, or anything can happen. So we need to be, I always tell to my students, these areas are so much open. So you need to keep your head open and be prepared to anything, even things that you can't imagine.
Yeah, yeah. Well, and if I remember right, and I believe Werner Vinge originally wrote about this, and then Ray Kurzweil has popularized it and definitely extended it. You know, one of the core ideas of the singularity is that when machines reach a human level of intelligence, perhaps a little bit less, perhaps a little bit more, they'll be able to bootstrap themselves into some kind of machine superintelligence, which basically creates a runaway effect, right? So these machines will go from what we think of today as a computer to something that could potentially have almost like a godlike level of intelligence. And this singularity posits that this could happen almost overnight, right?
Yeah, and the Kurzweil even gives a pretty limited time scale for this, a few decades. And I really think that in a few decades, the power of computers and AI will be much more than today. Will it be enough to cause this runaway? I'm not sure. Shall, if we want to keep control, probably humanity will have some mechanism that will keep humans in control and avoid this revolt of the machine or some catastrophe that they will not be able to withstand machine power and AI, which will be self-thinking and will extinguish humanity. So probably our engineers and our software people are pretty smart. So I hope they will be able to foresee and prepare for such possibility and make it gradual or only controlled by them. But maybe I'm wrong. Maybe this will happen like in science fiction that machines take over.
Yeah. Well, what's interesting, and again, this goes to your paper, and this was one of the aspects of this intersectionality that really intrigued me was, so you were looking at the singularity and saying not only will it happen here on Earth, but this is probably something that happens in every technological civilization, right? And so right now there are something like up to 400 billion stars in the Milky Way galaxy. The Drake equation predicts that there are potentially dozens to even hundreds of thousands of alien civilizations that are technologically advanced that may be out there.
No,
And
I don't agree with such sharp numbers. I would say that the Drake equation predicts that there are between 1 and billions of civilizations. We have no idea. We cannot fine-tune the Drake equation, although I remember one of your questions is about the contribution of Kepler. So this contribution of the last, particularly the Kepler mission, but also the following missions that found thousands of exoplanets, and you can take it one step further, make the statistics, and you find that maybe every star in the galaxy has a solar system, and between 10% and 50% have an Earth-like planet in their habitable zone. What do you want more? It's exactly like us. But this is not enough, because there are three more terms in the Drake equation of which we have no green idea. One is a biological term. Most astronomers now think it is close to unity. The biological term means what are the chances or statistics that a planet that has all the conditions like Earth, that is Earth-like and has a right temperature and liquid water, what are the chances that will develop biological life within a few billion years, like it happened on Earth? So this could be close to unity, which means that every such planet eventually will have biological life, but it could be also much less than unity. There are many ideas like rare earth that say there are some more parameters there that we don't know, hidden parameters that make Earth very unique, and perhaps life is very few. So I'll get back to it in a moment, because in a few years, maybe James Webb will give us the answer if it's close to unity or close to zero. But let alone F biology, there are two more parameters in the Drake equations which are even less well known, or even less, you can guess, hardly you can guess them. And one of them is F intelligence. I combine the F intelligence with the F communications to one. So this means that if biological life already developed on a planet with the right condition, what are the chances that within a few billion years it will develop intelligence and communication? We have no idea what this parameter is. Even the ones who say that FB biology is close to unity don't dare to say it about F intelligence. And then the last term, which is known least of all, is a duration of an intelligence or a communicative intelligence. Some scenarios say it may be only a few hundred years, which could fit Earth. We only started broadcasting to the stars, or actually using radio wave, which go also to the stars, even if we don't intend to, only less than 100 years ago. So if humanity develops more and in a few hundred years it goes into a silent channel like fiber optics, which does not send any radio wave to the stars, and if many other communicative civilizations like this act similarly, then the term that is usually called L in the Drake equation is only a few hundred years. And if this is the case, there is only one civilization or very few civilizations in the whole galaxy. So the result is very sensitive to these three unknown parameters. So I think it's very, very far going saying that we have tens of millions or tens of thousands or any number which is different, any estimate that is different than between a few and a few billions. I think we cannot say any more precise than this.
Yeah.
And if you let me, I can explain why in a few years we may know one of these parameters, FB.
Absolutely. Absolutely.
Yeah. So if the biological factor, we can actually soon, hopefully, will be able to tell if an exoplanet is a biotic exoplanet. How can we do this? in the same way that we found the water vapor. Even Hubble found water vapor on an exoplanet in 2019. This planet that I think was called the K2-18b. It is a planet which has extremely favorable conditions for finding the spectrum and isolating it, because it's transiting its star. And as such, when Hubble looked at the atmosphere, he could see the difference between the wavelengths of water vapor and the same picture in another wavelength, or the continuum. And he saw that in the water vapor, I'm making it very simple, but it's really not so complicated. In the water vapor, there was more absorption. So the planet looked a little bigger. So the atmosphere was absorbing more. So it could calculate what is the fraction of water vapor in the atmosphere. And this is the first step. Now, if we could do the same thing for oxygen, it is more tricky, but James Webb is more powerful. And James Webb already did what Hubble did on many, many hours. He did it in less hours in a much higher quality. This is one of the pictures that NASA published on July 12th. Another exoplanet that James Webb looked at it and was able to establish water vapor. Now, if James Webb assumes that James Webb will find similar signature for oxygen or ozone in the atmosphere, this may indicate that we have a photosynthesis there, because Earth is the only planet in our solar system that has oxygen in significant amounts. And although we know that oxygen can be produced non-biologically, for example, by photolysis, the separation of water into oxygens and hydrogen, but oxygen in combination with some other, what is called biosignature, like methane and the right quantities of water vapor and CO2 and maybe even more, this will give some confidence about finding life there. Now, suppose that we have a sample of 100 exoplanets, which James Webb can look at them quite well. And James Webb finds this combination of oxygens and some other biosignatures on 30 of these 100 exoplanets. Then one could pretty robustly estimate that FB is equal 0.3, 30 over 100. If James Webb, however, finds none, then one would say an upper limit, and FB must be less than about 0.01, 1%, because we have 100 planets, found none of them biosignature, so it is at most 1%, but it could be, of course, much less. So in such a sufficiently naive way, I should say, one could roughly estimate. Of course, the big question is if our biosignature is a good measure for life. But that's as far as we can do in the present technological level. And I think I always tell my students, every course, every year, you are closer to the biological singularity, when we'll find life or deny life on exoplanets.
Yeah. Well, and thank you for explaining that. So that is where life begins. But again, one of the things that excited me so much about your paper is that it sounds like you and your colleagues were suggesting that the singularity is a part of natural evolution for every or for most intelligent species, right? So as a species progresses, they begin biologically, and not surprisingly, we're seeing this in our own habitat, where over a period of years or eons or whatever, the planet changes, resource depletion happens, the environment changes. Maybe that's natural, maybe it's caused by the expansion of their civilization. As technology increases, perhaps this singularity is something that's inevitable as an evolutionary stage, part of natural evolution for every species.
Yeah, as you said, it may very well be, because there are several factors that are pushing towards it. depletion of resources. Also, if you want to go on interstellar voyages, machines are much more fit to do this because of the radiation and because of the long duration. And however, I would not dare to say that this is every civilization is doomed to reach this point. We know so little. We don't know even about our own civilization, if it will reach singularity, not to speak about what will happen after it reaches singularity, if it will turn into 100% AI machine controlled life, or side by side, humans and machines will live, or any other. So we only have one example, which we don't yet know because it's in our future. But as you say, if you want to make the logical conclusion, we are still so young, so we are a baby culture intelligence in terms of space culture, and we are just our planet is 4.5 billion years old, and there are so many other stars with planets which are 6 and 8 and 10 billion years old. And what happened only in 3.5 billion years on Earth, life from nothing, it became to thriving complexity of biological life. And then another 100,000 years, intelligence, language, and in another 100 years or 200 years, technology. So it's accelerating. So this is why people think, and I agree, this is very plausible, that sooner or later any civilization will reach the point that Earth is now and beyond. And what will happen when it's beyond, I don't yet know, but the scenario of AI-controlled life is a really attractive one.
Yeah, yeah. Well, and it is interesting that you mentioned this idea of side by side. And in some ways, in at least a rudimentary way, that's already what's happening. We have robotic probes, satellites, all sorts of machines exploring Mars currently. We have a pretty extensive infrastructure growing in the Mars habitat, and it's all machine based, and it's sending information back. Now, it's not AI, not yet, but presumably as our science continues to develop, especially if we cross the singularity, it doesn't strike me as unreasonable to think that our machines would do exploring of the cosmos, and human life could remain as it is right here at home.
Yeah, absolutely. I agree that actually I would think that Perseverance, the last rover on Mars, and its landing on Mars was already partially AI, because there were this 7 minutes of horror when it passed through the atmosphere of Mars, and there was no contact with it. And even if there would be radio contact, there were 20 or 40 light minutes away from Earth. There were by no way they could respond through contact with Earth. So they had to be autonomous. And so is now the rover on Mars. If there is, for example, a pit and it's not prepared, it will fall into it. But it has the AI capability to analyze it. It's not, of course, maybe like an autonomous car, but it will get better and better, I'm sure. So we are already on the verge of autonomous space exploration, yes.
Mm. Now, if it's okay, I'd like to ask about the UAP phenomena. And this is something that's still very controversial. I'm not sure if anyone has any idea what's actually happening there, but it has been suggested that this might be extraterrestrial in nature. If that is the case, is it possible that what we've seen in terms of UAP are actually some of these post-singularity robotic probes, maybe exploring our planet in the same way that we explore Mars?
Yes, of course, this is a very attractive idea. I would personally, I would leave it to science fiction. mainly not because I don't believe it's possible, but mainly because as teaching astrophysics for over 30 years, I know how big are these and how unperceptible are these distances. And as you said yourself, 400 billion or 200 billion stars in the galaxy makes this number incredibly high. Combined with the huge distances, it's very, very unplausible to me that another species will spend so much focus, so much power or resources to explore the solar system and Earth, because Earth, after all, it looks, if you look at it from far away, from a distance larger than about 100 light years, it looks like a simple biotic planet. Okay, they can analyze the atmosphere, they see it's oxygen rich, okay, they have life. But as I said, most astronomers today believe that FP in the Drake equation is close to unity. They have actually access, or they know hundreds of billions of biotic planets. So Earth is not special in no way. It could be special if intelligence would be rare or relatively rare, if they would know that Earth has intelligence, but they don't know yet because they are too far away. They are beyond 100 light years, which is nothing compared with the galaxy. It's a very tiny region. Our galaxy is 100,000 light years across. So they don't know yet, and they don't have any reason to dedicate many resources exactly to Earth and not to other tens of billions of biotic planets, that most of them are probably closer to them than we are. And I took this as one step further, and I wrote a paper which is coming up in the Astrophysical Journal that makes a mathematical computational exercise to ask what is the chance that out of, say, 1,000,000, of course, this is a parameter, we can say 10,000 or so, civilizations in the galaxy, will find the civilization that is closer to us than 100 light years, that they would know already that we exist. Actually, you need to make it closer than 50 light years because they need to get our first signal, radio signals, and send it back. And if it turns about object, about spacecrafts, about robots, you don't expect them to move at the speed of light because it's very, even if they have the capability to send at the speed of light, it's very costly, and they don't rush. They could put it for a fraction of the cost. They could accelerate it to about 10% of the speed of light or 1%. They have ions. They don't need to be very fast. But if they want to explore as many planets as possible, they will probably divide their resources. So you can make a calculation how far can a civilization be to get our first radio signals sent less than 100 years ago and get to us with a robot that has about 10% the speed of light or 1%. Make it another parameter. No. So when I did the calculation in this paper, I find that the probability is very, very low unless n, the number of civilizations in the galaxy, is very, very high, over tens of millions. So it doesn't say, I don't say it's not possible. I only say the probability that so many, or even one, has arrived that is a robot is very low. This must be a very, very big coincidence that we happen to have out of, say, million civilization, we'll have one that is closer to us than 100 or 50 light years. But there is another thing about this idea, which makes it even more interesting and even nicer. The number of 100 light years, I call it the radiosphere. it is a sphere of radio waves that Earth began to unwillingly send into space when we first started shortwave radio communications, radar, TV, and so on. Now this sphere is expanding. When this sphere increases, eventually it will reach the closest civilization to us. And the closest civilization to us, statistically speaking, one can calculate the distance once you assume with the number of civilizations in the galaxy. It's a very simple exercise. And as a function of n, the number of civilizations, you could calculate how long you have to wait till it will reach. And for fiducial numbers like maybe 1 million or 100,000 civilizations evenly scattered in the galaxy, because we don't know better than evenly, but this will have a number. I reach a number in this paper of about 2,000 years, few thousand years. So I call it the contact era, an era when we, or actually any civilization, after it exists as a communicating radio emitting civilization, it becomes other civilization could catch it, the radio waves, and discover it. And if indeed the civilizations are not so numerous as biological planets, send robots to explore it, or even send radio waves to explore it. And this is actually SETI. We hope that some civilizations that has detected Earth already will send a directed signal to Earth, or maybe beacons that have been scattered in space will discover Earth, and so on. So really, this tells you that any civilization, depending of course on this parameter n, but it is not so very sensitive to n, after a few thousand years, when it reaches already radio capability, even if this stage is not very long, but the first radio waves already scattered into space, then they have a chance of getting an expedition or a robot from another neighbor civilization. I'm not saying that what we saw now is it became very famous, Oumuamua, that also my friend Avi Leb has this hypothesis that this is actually a spacecraft, maybe disabled, maybe after many years of erratic movement, not necessarily sent to explore us, but it could also be not active, but still something. I'm not saying this is not possible. I'm only saying that the chances that this was sent to us on purpose because they discovered us before are very, very low, given these few assumptions that I mentioned.
Yeah.
And the same thing, in the same way, I forgot, of course, the same idea goes for, of course, unexplained aerial phenomenon, which is the new term for UFOs. Yes. We have hundreds or more than 100 sightings in this report of the Pentagon published last year. 100 or more really reliable people, pilots and serious people. But the special thing about this report is for the first time, an official report of the Pentagon says, we don't know. It admits that these are really reports we cannot explain. Many others were explained by atmospheric phenomenon or, I don't know, test aircrafts or whatever, but these 100 or more are unexplainable. Of course, it doesn't say that there are extraterrestrial intelligence, but it could be, or at least few of them could be. And yet, in this case, it will be very unlikely that they have been sent on purpose to us. They could, of course, be these objects, artificial objects or robots that are exploring the galaxy for millions of years, and there are programs, autonomous, and autonomously reach places for which they detect signals or biological signs or whatever. But sent on purpose, the chances are low, but they increase. So within a few thousand years, we'll have better chances, of course, given that we have some civilizations in the galaxy except from us. If we are the only civilization, then the chances are zero anyway.
Wonderful. Amri, let me thank you so much for your time today. I genuinely, it is an honor. I can't thank you enough for joining me. Let me close by asking what organizations like SETI could change to more closely monitor for post-singularity technosignatures.
This is a really great question because indeed SETI has worked now for more than 60 years and no single success. This, of course, does not say anything about the technology of SETI, that if they are wrong or if they could do better. But if you look for AI instead of SETIs that we know, the broadcasting, it could be so different than what we know. Post-singularity could use not radio wave, but quantum entanglement, things that we are just beginning to understand. And we really need to be open. And I think SETI people are quite open-minded, but yet it's still possible to go to other wavelengths. People are doing it, like looking to laser and other wavelengths, not only radio, but also some other conceptually different things that we can only guess because we ourselves have not yet reached the singularity. So we can only guess what will happen, and keeping our minds open and asking the new brains, the new minds to tell us, maybe AI people, maybe software people, to tell us what to look for, could be a new way, could be something that will maybe discover something new that we did not yet. Always when you're going on a new road, you find something new.
Absolutely. Amri, thank you again, sir.
Thank you. Bye-bye.